The first thing that we want to look at here is being able to solve an exponential function. When we look at solving exponential functions, we're going to look at two kind of different methods, and it depends on what the equation looks like. So one type of equation that we could see is when I've got an exponent only on one side of the equation. So something like that may look, for example, like 3 to the x plus 7 equals 9. All right, so what I notice here is I've got an exponent on one side of the equation. So what I want to do here is I want to isolate the base, which this one is already isolated. What I mean by that is that the only thing I have on one side is the base and the exponent. All right, once I've done that, then I want to rewrite this into a logarithmic function. So we're going to use our properties that we looked at for exponentials and logs, and we want to rewrite this. So remember, to rewrite this, I'm going to take that 3 and I'm going to make it a log base 3. And then I'm going to switch the 9 equals x plus 7, right? Remember, we called that kind of the around the world. All right, so now what we want to do here is on this left-hand side where I've got my log, I can solve this using my change of base property. So I can rewrite this with my change of base property, log 9 divided by log 3 equals x plus 7. Now all I need to do here is go to the calculator and type that in. Log 9 divided by log 3. Typing that in, I would get the number 2 equals x plus 7. And then I just continue to solve. So I'm going to subtract that 7 from both sides. Right? And that would be my final answer. So let's look at another one. Let's say, for example, we had 12 to the 2x minus 3 equals 5. So what I would want to do here, again, make sure that the only thing I have on one side is an exponent, a base in the exponent. So then what I'm going to do is I'm going to introduce the log. So I'm going to rewrite it. So I would have a log base 12 of 5 equals 2x minus 3. Then I would use my change of base formula here. So I'm going to have log 5 divided by log 12 equals 2x minus 3. Now, at this point, there's two options here. So typically in my math lab, it will tell me to leave this in terms of log. So what that means is that they don't actually want me to type this into the calculator. Instead, what they want me to do is just pretend that I did. So if I were to continue to solve this, I would add a 3. So I would have log 5 divided by log 12 plus a 3 equals 2x. And then if I kept solving, I would divide by 2. So I would have this long answer, but it is in terms of log. So that is what my math lab may want as your answer. Now, for me, it's just as easy to go ahead and go type it in. So if they do not tell me to leave it in terms of log, instead they're going to tell me how much to round to. So they'll say round your nearest answer to, or round your answer to the nearest hundredth or something like that. Then what they want me to do is, just like in the last problem, I would go type this in to the calculator. So typing in log 5 divided by log 12, I'd go type it in and I would get about 0.648 equals 2x minus 3. So all I did is I could go type this into the calculator, right? Get some decimal, and then I would continue to solve. So I'd do the same process I did before. I'd add my 3, so now I'd have 3.648 equals 2x, and then I would divide by 2. So my answer would be x equals about 1.824. All right, so depending on what my math lab asks me to do, depends on if I'll actually type it in as we did here, or if I would leave it in terms of log. All right, so let's try one more just to make sure that we've got it here. All right, I'll come up here. So let's say that we wanted to look at 16, 2x plus 5 equals 2. So we would start off and I would rewrite this into logs. So I would say log base 16 of 2 equals 2x plus 5. Then I would go to my calculator and I would type this in as log 2 divided by log 16. Typing that in, I would end up getting 1/4 or 0.25, whichever way. Then I'm going to finish solving. So I'd subtract my 5. So let's just say that we use that as 0.25. So I'd equal negative 4.75 equals 2x. Divide by that 2. So I would end up getting that x is equal to a negative 2.375. Right? So now I can solve an exponential function if I have exponents only on one side by rewriting into a log function using that change of base and solving.